So I believe, hopefully you, before you did this recording, you actually watched a brief little video on the formation of our solar system. So our solar system is the sun, the 8 planets, the Kuiper belt, the Oort cloud. It's everything that orbits the sun. And how did our solar system come to be? So here's a figure from your textbook. I'm going to kind of talk you through it. This is actually called the condensation theory. If water condenses, think about that. When water condenses, it's going from steam or a gas to a liquid. Actually, steam, if you can see it, that is a liquid. So water vapor to water liquid. And so this condensation theory kind of talks about over time how and it was cooling and it was time, and basically things kind of coalesced or came together. So the term nebula, and I think we'll actually hit that later on in this class. Anytime you see nebula, that actually is a cloud of gas and dust in outer space. Most of outer space is nothing, but if you get to something and it's not well formed, it might be a nebula. Actually, well, I'll get there. So our solar system began with a cloud, a nebula, and that nebula began contracting. So we have this right here, number 1. Okay, then you see number 2 and number 3. What happened, and we see this actually in other stars, is can you see that we have a couple of arrows here in number 2 kind of showing the rotation. So this thing started contracting, and the nebula began contracting, and it began rotating. And as it rotates, actually particles begin to kind of come together. And here for number 3, can you see kind of some, they're coalescing, they're making large objects. Okay, so those large objects actually are baby planets. The term planetesimal means planet that's not quite a planet yet. Okay, proto-sun is like a prototype. Okay, in here at this stage we actually have something that's getting larger, it's picking up mass, and it's heating up. Okay, and that's just kind of a consequence of its contracting and rotating. Then step 4 is we have kind of over time, and I can't remember, I think 100 million years maybe. So this process from step 1 to step 5 over here, which is our solar system, took maybe 100 million years. So you can kind of see, if you compare 3 and 4, actually the objects, the planetesimals, are getting more distinct. And they're getting more distinct, and actually now, after planetesimal, you get a protoplanet. So then we have a fair bit of time, but an important thing occurs between 4 and 5. Because if you compare 4 and 5, okay, here with 4, can you kind of see the dusty regions? Okay, and 5, there's no dust. And the other thing about 5 is we have a full-fledged star here at 5. Basically, remember I said up here that the sun was going to be in the middle. It's getting larger and heating up. So here finally at 5, the sun begins, it got warm enough and it got enough mass and enough pressure in the center that in its center, in its core, it began nuclear fusion. Okay, so actually date-wise, and in this class I want you to know a couple of dates, and one of them, B stands for billion, YA years ago. One of the dates I want you to know is that this happened about 4.5 billion years ago. Okay, so about 4.5 billion years ago the sun turned on, and actually it created something called solar wind, and it kind of, I call it flashing, but it kind of cleared out the extra sort of dust that had not been associated with a planet. So that's kind of how we go. Okay, that kind of in a nutshell. Now I learned it as the nebular theory, but this is, I think the nebular theory and the condensation theory are very similar. All they are is talking about how our sun came to be through these overall steps.